Alright guys, welcome back. I'm going to do a very quick video just explaining the process I've gone through in designing the procedural world generation. So basically what I want to do is generate a very large scale procedural solar system with potentially billions of objects like asteroids and minor planets and that sort of stuff. So I've had loads of issues with this. So my first approach was to use a grid. Right? So what I ended up with was a grid of, as you can see, a grid centered on the sun. The grid cells are 1,000 kilometers in width and height, and they're represented using the coordinates represented using an int32. So that gives us approximately 28,000. That's a typo. 28,710. Let me just double check that number. Got it written down. Where is it? That gives us 28,700 square AU per side of this grid. So that gets us all the way out into, like, you know, the helio what's it called? Not the heliopause, the magnetopause. They're basically the bubble of solar wind that the solar system sits in. That gets us a massive solar system, right? And plenty of space to explore. But it gives us some problems. So the idea is that as the player moves from grid cell to grid cell, the next bunch of procedural objects would be loaded in. And in the kind of the demo that I showed very early on, I think it's probably the third or fourth video on my on this channel, that worked great. So it loads in asteroids. They move as you move through the world, it will keep loading in asteroids forever, which works great if you want to travel through a big infinite or pretty much infinite asteroid field. But when you start adding in things like planets that are orbiting each other, it then starts to break down. So what I came up with was, using the grid cell, all the planets would be statically, like, fixed in space. So the planets wouldn't move, the moons wouldn't move around the planets, that sort of thing. And then the probability of things appearing inside the grid cells would be based on the proximity to a planet. So if you're close to a planet, you'd get a moon appearing in orbit around that planet when you travel into a grid cell. However, this also, you know, adds in more problems in that there's it didn't really scale very well. So on like a solar system scale, on a moon-sized scale, if you want to add in moons around Jupiter, this system didn't work very well. So that then took me to a second version of this, which was using grid cells but with a sphere of influence. I don't know what I was writing when I did that. Anyway, so basically we've got the same grid cells and the sun is at 0, 0, right? But then around each planet, it then has separate grid cells which are selected based on a radius around the planet. As you can see, I've like kind of roughly got these, and those grid cells have an offset. So the planet's position in grid cell coordinates is the offset for those, so that then things appearing in those are referenced to the planet. So the planet is at 0, 0 for everything inside this. It works better for building moon systems and stuff, but it still had the problem that all of the planets were kind of static. So as the planets moved around, these cells will, the cells that are in the sphere of influence of the planet will change. But it's still problematic. It's still not quite right. So then that is plan 3. So I didn't get very far on this one because it just worked out to have too many problems. This is using radial grid cells. So centered on the sun, you have grid cells that go out, and they're based on polar coordinates, right? And then centered on each planet, you then have polar coordinates that deal with drawing all the moons and stuff. So the problem with this is that as you get further away from the object that you're parented to, the grid cells get larger. So really close into the sun, the grid cells are tiny. Really far out in the Oort cloud, the grid cells are huge. So this was kind of like pretty much a fail from the start. But it did get me on the right track of using polar coordinates for generating things. I think polar coordinates is the way to go. So that gets on to my final design for this, which is what I'm going to go and program now and do another video on. So this is not, don't use grid cells at all. Procedural generation is going to be based on the player's position and the player's view range, not on any of this other stuff. So the way this is going to work is the player's position is expressed as a polar coordinate relative to the sun, or relative to the nearest object, right? What that will then do is we can use that as a seed. So the input parameters for our procedural generator are going to be player position, player view range, and some sort of probability distribution. So those are our inputs to the procedural generation function. The probability distribution will say at this point in space how likely are things to occur, what sort of inclination are they likely to be in, what resource density is there, what masses there are, all that sort of stuff that is used to actually generate the objects. The player view range will be used to select which objects to generate, and the player position will also be the seed for the random. So this whole set will be the seed for the random generator. So what we then do is we generate the procedural objects, right? So we would generate objects whose orbit intersects this sphere of view range. So as you can see here, I've got 3 objects that have been generated. All of them intersect the player's kind of view sensor range. So the player could potentially detect any of these 3 objects, or all of these 3 objects if they're in the right position. So we got that. Then what we want to do is, using the current time in the game world, or the current date in the game world, work out whereabouts in the orbit each of these objects is going to be. As you can see, only one of these objects was inside the player's sphere, the player's view range at this date, right? And the others aren't. So we cull out those ones and we don't show them to the player, and what we do show to the player is the one that is actually visible inside their view range. Okay? So this is my plan, and what this gets us is the player is orbiting around the sun, right? Or the player is orbiting around the center of whatever it's orbiting. That gives us the ability to then generate objects that would appear around that object. So if the player was instead orbiting our guy up here, we can then use the view range to work out whether we want to create similar objects around this. So that's the plan. I think it's going to work. I think it's a much better way of doing it than anything else, than any of the other plans. So what I'm going to do is I'm going to try and set up a pretty basic demo scene, which will, with the player in orbit around the sun or whatever, just a central mass, generate objects in their own orbits as the player moves around. So it's going to be a player, which is basically going to be a rocket, a sphere of detection radius, and the random generator that procedurally generates objects that the player can see. That's the plan. Okay, thanks for watching this. It's a bit of a wordy one explaining what I'm doing. I just wanted to get my kind of thoughts out on a video, because this has taken actually quite a long time for just me to get my head around. I'd love any feedback on this. If people think it's a crap idea, it'd be really good to know now. If anyone can think of any problems in this, that would also be useful. So far I can't see any, but then I've been up really late. You know, I was up sort of at 4 o'clock this morning drawing this, so coming up with this plan. So I've had like 18 cups of coffee and a little bit jittery, probably brain not working good. Anyway, thanks for watching, guys. Rock on. See you in the next video, where I'm going to be programming this and we're going to see if it works. Awesome. Bye.